welcome back, calculus class. Today we have a very special program in store for you, and here to tell us about it is Ben Bearattack Barrand.
Hello, Abby's math class. My name is Ben Barrand. I guess you're wondering to yourself why we have these 3 pasta boxes in front of you, including rigatoni, Garfield's favorite, lasagna, and my favorite, Elbows Chiffrey. Well, I'll tell you why we have these 3 pasta boxes, because my group, including Sydney, Summer Tan, Chelsea, I Want My Cylinder, and Ben Barrand, myself, optimized these 3 boxes. We had to change the dimensions of these 3 boxes, however, because the bases were not squares. So we really didn't know how to find a prism without a square-based base. So instead, we changed it around to make it easier on ourselves. So to explain things a bit further with our newly optimized boxes, I will introduce Chelsea Cylinder.
Thank you, Ben. And here we have our finished product. We have our optimized rigatoni, our optimized Elbows Chiffrey, and finally our optimized lasagna. Now take a good look at these boxes, and what do you notice? Well, I'll tell you. All of these boxes, after optimizing them from the plain regular boxes, are the same shape. That's right, they're cubes. And in this infomercial, we are going to explain to you how we optimize these boxes.
Starting with Sydney Summer Tan.
Hello, ladies and gentlemen, Sydney Summer Tan here, bringing you this old box of rigatoni. Do you hear how little pasta is inside? Because of these dimensions right here. 7 1/4 by 5 by 5, which was originally 3, but because we don't know college calculus, we had to change it to 5 to make it a square prism. Now, the surface area of this box is 195 inches squared, while the volume is 181.25 inches cubed. While keeping this original surface area, we are going to change the volume and make it this new optimized box. Now, let's see how much pasta from this box can fit in here. Do you see how much room there is left in that box? We can fit a whole another box of pasta in there. Because after optimizing, we have found out that each side should equal 5.7, making it a cube. That's right, boys and girls. Look at how much pasta there is in there, and look how much more we can fit in there. Back to you, Chelsea. I want my cylinder.
Thank you, Sydney. And now let's examine our second box of pasta, the lasagna. Now look at this boring rectangular prism. It had original dimensions of 7.5 inches in length, 2 inches in width, and 4 inches in height. Now, in order to optimize this perfectly, like the other 2 pasta boxes, we had to change the shape and make the base a square. And because we did that, the width became 4 inches. Now you can see that we had our original surface area and our original volume, and we went through the whole optimization process, and we found that the optimal volume of this boring box of lasagna is this newly optimized cube of lasagna. Now let's take a look at what can go inside the box. We originally had pasta that could fit in this box that was this size. Well, unfortunately, this piece of pasta cannot fit in this box. So that is why we've created a new size of pasta. Now look at one thing that's pretty amazing with this, is that in this box, only 16 pieces of the big pieces of lasagna could fit. But now with our new optimized box of lasagna, you can fit 80. Now how could you miss out on that? And now to talk about our third and final box of pasta, we will go to Ben Bearattack Barrand.
Thanks, guys. So now we've got my favorite pasta of all, Elbows Chiffrey. So I guess you're wondering, what else did we do to this Elbows Chiffrey? Well, I'll tell you what we did. We created an optimized box. Take a look at this. Oh, very nice. Yes, indeed. Well, now I'll bring your attention to the board over here. And as you can see, like my other members, we had to change the dimensions of the pasta box so that we could calculate it. As you can see, we made the height 4 inches, the width 4 inches, and the length 7.25 inches. We drew the surface area and determined that it was 148 inches squared, And we also determined the volume and found that it was 116 inches cubed. As we travel over here to the actual section, we attempted and successfully found y, which is y equals 37 over x minus 1/2 times x. Once we found y, we plugged it into the volume, eventually coming up with 37x minus x cubed over 2. We took the derivative and got an x value of x equals 4.9 inches. And bringing your attention over here again, we were able to determine that the optimized dimensions of our pasta box for Elbows Chiffery is 4.9 inches in length, 4.99, inches in width, and 5.1 inches in height. And our final volume was 125.2 inches cubed. Thank you very much.
Now that we've examined 3 different types of pasta boxes, let's take a closer look at the shelves. When we went to a supermarket, we found that a shelf has dimensions of a length of 48 inches, a height of 11 inches, and a width of 21 inches. Now let's take a look at how many unoptimized boxes of pasta can fit on the shelves versus how many optimized boxes of pasta. Let's first look at the lasagna. When we looked at the lasagna, we found that 6 of these unoptimized boxes of lasagna could fit on the shelf stacked next to each other. We found that 5 of the boxes could fit stacked behind each other, and 2 of the boxes could fit on top of each other. Now with the optimized box of lasagna, we found that 9 boxes could fit stacked next to each other, 4 could fit stacked behind each other, and 2 could fit stacked on top of each other. Now, let's look at the Elbows Chiffery. We found that with this unoptimized box of pasta, that 12 of the boxes could fit stacked next to each other, 5 could fit stacked behind each other, and only 1 could fit stacked on top of each other. With the optimized box of pasta, we found that 9 could fit stacked next to each other, 4 could fit stacked behind each other, and 2 could fit stacked on top of each other. Finally, let's look at the rigatoni. With the unoptimized box of rigatoni, we found that 9 could fit next to each other, 4 could fit stacked behind each other, and only 1 could fit stacked on top of each other. With the optimized box of pasta, we found that 8 boxes could be stacked next to each other, 3 boxes could be stacked behind each other, and only 1 could be stacked on top of each other. Now you may be wondering, why can less boxes of optimized pasta fit on the shelves than with the unoptimized box of pasta? Well, you see, we have an answer for that. Because with this, we have more volume. And even if that takes up more shelf space so that less boxes can fit on there, we still have so much more pasta fitting in each of the boxes that it's still a much better deal.
Optimization of the home cart. Here we have Ben, just a regular person like you and me, going to the grocery store with his home cart. He even stops to talk to a few friends. And here is the math behind our optimization. The length of the cart is 17.5 inches, the width is 15.5 inches, which we had to change to 17.5 to optimize, and the height of the cart is 20.5 inches. The volume that we calculated was 6,278.125, and the surface area was 2,047.5. After optimization, we found out that each side should be 18.47 inches, and the end volume would equal 6,304.28 inches cubed. Therefore, the lasagna, the Elbows Chiffery, and the rigatoni, the optimized boxes, fit 3 stacked on top, 3 stacked behind each other, and 3 stacked side by side, making it 27 total boxes that can fit in the cart.
Optimization of the shopping cart. Here we have Sydney browsing the aisles of the supermarket looking for a great dinner. And this is the math to support our optimization. Our shopping cart had a height of 22 inches, a length of 19 inches, and a width of 19 inches. After calculating the surface area, we found that it was 2,394 square inches, and we found that the volume was 7,942 cubic inches. After going through the optimization process, we found that the optimized dimensions of the shopping cart were 19.97 by 19.97 by 19.97, giving us a cube. Therefore, when looking at the optimized lasagna and rigatoni boxes, we found that 3 could fit stacked on top of each other, 3 stacked side by side, and 3 stacked behind each other, giving us a total of 27 of both of those types of boxes. However, for the Elbows Chiffrey, we found that 4 could fit stacked side by side, 4 stacked behind each other, but only 3 stacked on top of each other. However, this gives us a total of 48 of the boxes fitting in the shopping cart.
Thank you very much for listening to our presentation.
We hope you learned a lot about optimizing pasta boxes.
And we hope that you buy our newly optimized boxes for $19.95 only.